Hello everyone. Let us now discuss how can we solve this problem. Minimum number of operations to make elements in array distinct. So we are given with an integer array nums. We need to ensure that elements in the array are distinct. To achieve this, we can perform the following operation any number of times. Remove three elements from the beginning of the array. If the array has fewer than three elements, remove all remaining elements. Note that an empty array is considered to have distinct elements. Return the minimum number of operations to make the elements in the array distinct. So, if we take this array given in the first example, now, first thing what I need to do is just like I am going through solving this example. I have one, I doesn't have one again, I have two, but I have two again, right? So, what I need to do is just like remove first three elements, right? So that I expect to be this array elements to be unique. Now I am removing the first three elements at one operation. So this took me one operation, right? Now I have 4, 2 and 3. Do I have 4 again? No. Do I have 2 again? No. Do I have 3 again? Yes, I have a 3 here. So I will remove the first three elements. Now this counts as one operation. Now I have 3, 5 and 7. Do I have 3 again? No. Do I have 5 again? No. Do I have 7 again? No. So the total number of operations is 2. Now let us look at the second example here. Let me check whether I have 4 again. Yes, I have a 4 again. So whenever I get a number which is again repeated, that means it is having more than one repetition or occurrence, then I will remove the first three elements. Now I have 4 and 4. Now do I have a 4 again? Yes, here just adjacently I have a 4. So this counts as one operation, this counts as another operation, and the total operations are 2. Now let us look at the third example, 6, 7, 8, 9. So let us look at first three elements. That's it. 6, 7, 8. Do I have a 6 again? No. 7 again? No. 8 again? No. 9? No. So total number of operations are 0. So if I use something like something to store the occurrences, I need to store the occurrences of every element. Now, how do I do it? I can use unordered map, unordered map in C++, and you can also use a dictionary in Python for the Python users. So what I do is using an unordered map. First thing which I'll do is is go through every element and increase its frequency in map. Let me name it as MP. So what I'll do is take MP, right? I am taking MP as an ordered map to store the frequencies of every element. Now I go to 1. I have 1 for how many times? I have 1 for only one time till now. Now I have 2. 2 for how many times? Only one time. 3 for how many times? Only one time till now. Now I have 4. I have 4. How many times? Only one time. Now I have 2 again. But 2 is already present in an unordered map. I will increment the frequency of the 2. Now I have 3. 3 is present for 2 times. Now I have 3 again for 3 times. And I have 5 here. So 5 is present for 1 time. And 7 again. 7 for the first time. So 7 for one time. So there are no something like same element repeated again in our map. So this is the thing with map. Now what I'll do, I'll go through nums with an index, right? I will go through nums with an index. Let me say that I. Now, first thing I'll do is check whether the index minus, something like here I am having till now, these are the indices. If these all are unique, so these all are unique, then MP size would be equal to n minus I. So MP size, that means unordered map size, should be equal to I n MP size, right, n minus I. So this is the first intuition for this problem. So n would be something like here and n minus 1 will be here. That means if all the elements are unique, then this I is pointing at a point where all these elements are unique, and MP is also containing unique elements. But if it is containing lesser than I n minus I elements, then this will be false. And I will run a loop till while n minus I is not is equal to MP size. But wait, here what I will do here, let me tell you, here I am taking this while n minus I is not equal to mp dot size. What I will do in this while loop, I will take I plus 1 and I plus 2 and decrement the count in the mp array. So if I decrement I 1, right, it will become 0. Now whenever any element's frequency is 0, first thing I need to do is removing it. Now I have I plus 1, which is 2. So if I remove 2, decrement the counter, it will be 1. Now I have 3. So here it is 3. Now let me check again now whether what the I pointer should be pointing to. Here it is 0. Next I need to come here. So I plus 3. So in the while loop I will write something like I plus is equal to 3, right? So here is my I pointer. Now I will do the same thing again. 4 2 3. 4 is uh, decremented by 0 by 1, and then it will become 0. So I am removing it. So 2 again, 2 is decremented by 1 and I am removing it. Now 3 is decremented by 1 and it is 1. But here I have incremented my I pointer to this I. Now let me check n minus I is not is equal to mp dot size. N minus I is something like, here I have total size as 9. So n will be 9. 9 minus I will be 8, 7, 6. So 9 minus 6 is 3. But if you see, MP size is also 3. So this condition will fail. So I have written the code just like as simple as that. So this is the first thing. But I need to check another one by this example. Let me do this example, and I am doing something like a wrong where I need to add another condition. So 4 is present for 3 times, 5 is present for 1 time, and 6 is present for 1 time. So here I will be pointing here, and 4 decremented to 2, right? Now 4 is decremented to 2. Now if you see, 5 is decremented to 0 and 6 is also decremented to 0, and if I remove these two, the MP size will be 1. Now let me check, I plus 3 is pointing here. Now n minus I is not equal to MP dot size. What I am doing, I am checking I plus 1 and also I plus 2. I plus 2. So here, is there any I plus 2? No. So I need to add another condition while I is lesser than n minus 2. So only then I will check MP of MP of nums of I minus minus, MP of nums of I plus 1 minus minus, MP of nums of I plus 2 minus minus, and I is incremented by 3. Now, even then, even after this condition, there are 4. That means here I have the number of elements are 2, but here the size of MP, this is the MP size is just 1. So if n minus I is not equal to MP dot size, I will add this condition again. Then I will increment my counter. But don't forget to increment the counter here also. Then I'll return the counter here. So if you look at the code, I have written the code something like here. Unordered the map, and I have took the frequency of every element here, and count is equal to 0. Here I have given you like I, and here I have written index. Nothing changed, just the variable name. Index is less than n minus 2, and mp dot size is not equal to n minus index. I'll run this loop. So as I said, mp of nums of index minus minus, and if that means I am decrementing, if nums of mp of nums of index is equal to 0, then I am erasing it. So I am doing the same for index plus 1 and index plus 2, and index is incremented by 3 and count is also incremented. And even after doing 3 operation, that means taking 3 elements, if I am not achieving unique elements, then I need to increment the counter again. But how can I optimize it? So the optimized code will be something like, let us look at what we are doing. If I write here, here, and then here. So if I look at this 1, 2, 3, 3 is present again. So that I want to go to the next one. So first thing, if any element is present again, then I need to do one operation, right? Now let us see. Here I have a 3 again. Here I have for this 3 I have a 3 again. So I am doing one operation again. But what if I come to this index 3 and I found out this 3 for one time, and this 3 is again for another time. So that means here I need to remove this 3 till this plus this index, right? So I am having a 3 here. I am having something like 1, 2 and a 3, and then 3 comma 3 and 5 and 7, right? Now imagine this is the array. So here I have a 7, here I have a 5, here I have 3, here I have 3 again. So what does this mean? That means this should be removed, and also here I have a 3 again. What does this mean? That means after this index I am having a 3, but the most probably it might be just here, because if I have, you might say that there might be a 3 again here, 3 and then 8 and then 9. So if I have something like this, then the pointer will be here, and the next probability will be I plus 3. So this is the total intuition. That means if I got if uh, if I got the same element again at index I, then the count will be I plus 3 by 3. That's it. So how do this approach work? As I said, if this is any element is present again at this index I, so I am iterating from the right to left. So if it is present, then I need to remove this index. So if I am removing these three indices, then it will be something like I by 3, because the number of times I am removing is just 3 numbers removed is counted for one time. So I have 3, right? I again have this 3 again at this index. When I say I got this 3 here, that means I got 3 at this point, at the next triplet, right? At the next triplet. So I am incrementing I plus 3 by 3. So this will be my answer whenever I get a duplicate number iterating from right to left. So my answer, as I said, my wait a second, my answer will be iterating from I is equal to right to left. Just say it as right to left. Now I need to do something like, if current number is already present, already seen, then I need to return I plus 3 by 3, right? Sorry, by 3. But even after doing all these steps, like iterating from here to here, I didn't get any number which is duplicate, then I'll return 0 itself. So let me write it also. So I will return 0 at the end. Now here comes the question. I am iterating from here to here, but how do I know? How do I know? So how do I know whether an a element an element is repeated or not? So you can use a map, or you can use a vector int int to store the numbers, right? So what is the maximum range? 101, because here nums can be till only 100. So to store the numbers till the range of 101, right? So if it is repeated or not, you can use a map or you can use a vector int. I am using a vector int and array. So let me write the algorithm for you. First thing, scene of 101 is false. So bool, that means this is no seen for only 0 times till now. Nothing is seen for now. For I is equal to n minus 1, I is greater than or equal to 0, and I minus minus. What I am doing here, if it is present nums of I is seen, how do I know it? If scene of nums of I is equal to true, then I will return I plus I plus 3 by 3. But if I didn't found, return 0. But before that, what is this? I am seeing this nums of I. So that means I need to make this nums of I to be true. So scene of nums of I is equal to true. So this is the whole code, just 4 lines code to be executed, and n is equal to nums dot size. And I'll give you the 2 approaches link, submission link in the description. If you like this video, do share to your friends and do subscribe to my channel. Thank you.